Question 2, we have a ball falling vertically under gravity onto an inclined plane. Let's call this angle A. So we have a ball falling down like this. So I need to create an angle here. And this angle is going to be A as well. This is right angled. We can imagine another right angle triangle in here. So we have a right angle and these two opposite angles are equal. And then A will have to be the same. Now we take the plane as our y-axis, so this guy here is our j and this guy here is our I, and you can see I in this case is opposite A, so we're going to have the sign. If A is here and I is down here, opposite A is sine, so we're going to have to apply sine here. So the initial vector here is u sine A in the I direction, and we have u cos A in the j direction. Going down in this direction, so it's positive, negative, so we need to fill in A here. The tan of A is 4/3 opposite over adjacent, given 5, so sine A is 4/5 and cos A is 3/5, so u is 20 by 4/5 in the I direction is what's happening here, minus 20 by 3/5 in the j direction, which is going to give 16i minus 12j. So this is what's going on beforehand. Then it hits, and we know that the new over the old is equal to minus e. Set these up before, something like this, 16i minus 12j. We have a mass of m, so we've our before and after. It's not going to change in the I direction, it will change in the j direction. So we can say that p, the new divided by the old, which was minus 12, is equal to minus e, which is minus 2/3. So 3p is equal to 24. So the new velocity is equal to 8. So I have 16i plus 8j for my new. So finding the length of the first hop, we need s of x. S of x is equal to the distance traveled in the x direction, but we need time within there, so we're going to need the time when s of y is equal to 0. So when is s of y equal to 0? When is ut plus a half at squared equal to 0? My y is 8, so 8t minus going to have a half a 40/5 by t squared, which is 80 squared, 6400 over 3g squared, which is 9g squared. That one and that one cancel. We have 16 times 80 over 3g. 16 128, so 1280 over 3g. Plus 2 times 5 is 10, which would knock a 0 off. So that looks like 640 over 9g. 640 over 9g. Making them both over 9g will be 3,602.40. 3840 over 3g plus 640 over 3g, which will give 4480. 4,480 over 3g. Does that divide by 3? Don't think it does. I'm just seeing I left out that 4 up above, so I'm just going to get rid of this for a sec. This 4 here, I crossed it out. So 8/16 are 128 So 1280 over 3g plus, that'll be 4 times 640, 2400 and 160, 2560 over 9g. This works out to be then. So I make them both over 9g. I'm going to get 3600 and 240, 3840 over 9g plus 2560 over 9g. And that is going to give 3900, 6400 over 9g for s of x. Are we asked anything else? We were. The landing angle after the first hop to the nearest degree. So the landing angle. So we need velocity of x and velocity of y. Velocity of x, u plus at. So we need the time, which is this guy. So 16 was 16 the velocity for x and a for y. So 16, the acceleration was 4g over 5 times time, which is 80 over 3g. So I get 16 plus 480 is 320 over 8. 320 over 8 is 4t. Am I simplifying enough? I can divide 5 into 80 16 times. That's 64 over 3. And that's 48 over 3. 112 over 3. I don't think that simplifies any further. The velocity in the y direction is going to be the 8, didn't we say? 8 up above there. 8 plus 3g over 5 is the acceleration by 80 over 3g. Cancel my g's. Divide 5 into 80 16 times. And I get 8 plus 3 16s, 48 over 3 16. Is that right? Yep, that's right. Only I should have a negative acceleration in there. Just be careful. 8 minus 16 is minus 8. So we're asked for the landing angle. So the tan of L is equal to, it's minus v of y over v of x. So 8 over 112 over 3. So that would flip 3 over 112, which is 24 over 112. And the inverse tan of 24 over 112 gives an angle of, to the nearest degree, 12 degrees. And that completes this question.